Good morning, Algebra 1. Here is your lesson for today on geometric sequences. So we've talked a little bit about arithmetic sequences already this year. Remember, we played the rat game. We figured out the pattern, which was similar, which was different. So what I want you to do right now is go through and circle the sequences that are listed here that are not arithmetic. So if you want to make yourself a little note, remember that arithmetic sequences are sequences that have a common difference and remember that means that they increase or decrease using addition or subtraction. So circle the following that are not arithmetic. So here, to go from 2 to 4, I add 2. To go from 4 to 6, I add 2. And from 6 to 8, I add 2. So that one is arithmetic, so we're not going to circle it. So I'll let you pause this video right now and go ahead and circle the ones that you think are not arithmetic. So I hope that you paused the video and now you're back. And let's see, to go from 2 to 4, I can add 2, and from 4 to 8, that adding 2 process won't work. So this is not an arithmetic sequence. To go from negative 81 to negative 27 and then to negative 9, so I'm looking at this one over here, this is definitely not increasing by addition or subtraction, so I'm going to go ahead and circle that one over here. This one is a little tricky to look at, so what I'm going to do is make a common denominator. So I'm going to call this sequence 112. And something over 12, something, oh, let's make this a little bit neater here. I have 1, 2, 3, 4 terms. And I want them all to have a denominator of 12. So 6, this would be times 2, so that's going to be 2. This would be times 3, so up here I have 3, and this would be times 4, so up here I have 4. And it looks like I'm adding 1/12 each time, so this one is arithmetic, so I'm not going to circle it. Here it looks like I'm adding 4 and adding 4 and adding 4, so this is arithmetic. And we can go ahead and label these guys. Let's copy and we can paste up here arithmetic and here arithmetic. So let's keep moving along. To go from 6 to 3, I would subtract 3, and 3 minus 3 would put me at 0. So this one is definitely not arithmetic. From 32 to 16, I would subtract 16 and then subtract. So here, also not arithmetic. So these 4 sequences that you've circled above, and you can see that I'm reading right here, these are called geometric sequences. So just like we have arithmetic sequences that increase or decrease by using addition and subtraction, and we have those common differences. For our geometric sequences, we have common ratios. So for something like this here, we would say that D is equal to 4, and that D is equal to 2, and over here D is equal to 1/12. Oh, we skipped one. But here it looks like this is also arithmetic and that my common difference is -5 because we're subtracting 5 each time. So our geometric sequences have common ratios, and we'll go ahead and highlight or underline that word ratio instead of common differences. And ratios refer to the number that we multiply by. So in this case, looking here, here my common ratio, and you know what, let's do this in another color so that it stands out a little bit more. Let's do it in pink because tomorrow is Valentine's Day. So here my common ratio is going to be 2 because to go from 2 to 4, I multiply by 2, and from 4 to 8, I multiply by 2. So that one looks great. Over here, this one is a little bit different. how am I getting from negative 81 to negative 27? And some of us would say that I'm dividing by 3, but remember that when we look down here, when I talk about my common ratio, I'm only talking about multiplication. So my common ratio here would actually be 1/3. So remember that dividing by 3 is the same as multiplying by 1/3. And if I wasn't really sure if it was 1/3, I can always do negative 27 divided by negative 81. And negative 9 divided by negative 27. So I can figure out, going in this direction, what am I doing here? If I'm multiplying by 3, I'm dividing. If I'm multiplying by 3, I'm dividing by 3, going in the opposite direction. So looking over here from 6 to 3 to figure out what this common ratio is, I can say, what is 3 over 6? Or what is 3/2 all over 3? And when we simplify, we end up getting that my common ratio is 1/2. So again, the same thing over here. What is 16 over 32? Or what am I multiplying 32 by in order to get to 16? And again, I'm back at a common ratio of 1/2. So geometric sequences, so a really important note about these common ratios is that we talk about them in terms of multiplication. So dividing by 3 is the same as multiplying by 1/3. So what I want you to do right now is I want you to go ahead and fill in sort of some similarities and some differences between our arithmetic and geometric sequences. So for example, they're both sequences with a specific pattern. Right? And you can probably add a few other things in here. What are geometric sequences specifically? So go ahead and fill in a few things here. And I kind of want you to just information dump everything that you remember about arithmetic sequences, right? Remember that if I had an arithmetic sequence and I wanted to find, let's say, like the nth term. So instead of finding the 27th term, I could find the nth term, and we had an equation for that. So I'm wondering if you can go ahead and remember what that equation was. Then I want you to come down here, let me know if these sequences are arithmetic, geometric, or neither, and then go ahead and find the next 3 terms. And your overall goal for today is to come up with an equation to find that nth term of any geometric sequence. So I think that we called it a of n is equal to, and I want you to go ahead and fill in what you think this would be. So let's just come and take a look up over here at, let's look at letter E, and let's do this one together. I can see that 8 minus 2 is going to give me 6, and that 14 minus 8 is also going to give me 6. So this is arithmetic. And I can do 22 plus 6, and that's going to give me 28. And if I add 6, I'll go ahead and get 34, and plus 6 will go ahead and give me 40. So I know here, and I'm just going to give you a little refresher on these arithmetic sequences, that my common difference in this case is 6. And u of 1, which remember that was my notation for the first term. The first term in this case is 2. So then what we did was we came up with this equation where we took our first term and we said u of n, I can figure out any term number in this sequence, and I can start with my first term, and what I'm doing is I'm taking my common difference, which is 6, and I'm adding it to the previous term. So we did that n minus 1, so I hope that this is sort of ringing a bell here. We had that u of n is equal to u of 1 plus our common difference times n minus 1. This is digging back to well before the holiday break, so I'm hopeful that we're remembering this a little bit here. So I want you to come up with your own sort of sequence or your own equation here, but make sure that it applies to geometric sequences and not arithmetic. So one of the biggest differences between those arithmetic and geometric sequences is arithmetic is addition and subtraction and geometric is multiplication. So I don't think that it would be beneficial for you to try and plug in sort of some geometric values into here, especially because we have this really big addition sign sort of staring right at us. And addition is not what we're working with here. It sounds like we're working with repeated multiplication, and that's a pretty big hint for you there. Repeated multiplication. So I'm hoping that we can come up with an a of n or a u of n, whichever variable you'd like to work with here. Create an equation that can be used to find any term for these geometric sequences. And when you finish, I have some other problems for you to work on. But for now, my main goal for you today, so your goal for today is to come up with an equation to find the nth term of any geometric sequence. So if I asked you to find the 5th term or the 65th term, that you have an equation that would help you reach that term. Good luck, guys, and we'll chat a little bit about this when I see you in class next. Good luck.